Good morning, students. Welcome to the study of Science 1, Chapter 1, Gravitation. Today, we will understand the topics free fall motion of a body, gravitational potential energy, and escape velocity. First, we will understand free fall motion and gravitational potential energy. So, come on, let's understand free fall and gravitational potential energy. Students, today let us understand free fall motion of a body. To understand free fall, try this simple experiment. Take a small stone, hold it in your hand. Which forces are acting on the stone? Now release the stone. What do you observe? What are the forces acting on the stone after you release it? The forces which are acting on the stone are the force exerted by the person holding it, the force exerted by the air, and the earth's gravitational force. After releasing the stone, it falls on the ground. The forces acting on the stone after releasing it are the force exerted by air and the earth's gravitational force. We know that the force of gravity due to the earth acts on each and every object. When we were holding the stone in our hand, the stone was experiencing this force. But it was balanced by a force that we were applying on it in the opposite direction. As a result, the stone remained at rest. Once we release the stone from our hands, the only force that acts on it is the gravitational force of the earth, and the stone falls down under its influence. Whenever an object moves under the influence of the force of gravity alone, it is said to be falling freely. Thus, the released stone is in a free fall. In free fall, the initial velocity of the object is zero and goes on increasing due to the acceleration due to gravity of the earth. During free fall, the frictional force due to air opposes the motion of the object, and a buoyant force also acts on the object. Thus, true free fall is possible only in vacuum. For a freely falling object, the velocity on reaching the earth and the time taken for it can be calculated by using Newton's equations of motion. For free fall, the initial velocity u is equal to 0 and the acceleration a is equal to g. Thus, we can write the equations as v is equal to gt, s is equal to 1 upon 2 gt square, v square is equal to 2gs. For calculating the motion of an object thrown upwards, acceleration is negative. That is in a direction opposite to the velocity and is taken to be minus g. The magnitude of g is the same, but the velocity of the object goes on decreasing because of this negative acceleration. The moon and the artificial satellites are moving only under the influence of the gravitational field of the earth. Thus, they are in free fall.
Freely falling objects and acceleration due to gravity. All objects, when dropped from a height, fall towards the earth. This happens due to the gravitational force exerted by the earth on the object. Suppose you drop simultaneously a small stone and a cotton ball of the same size from a height. Which of the two will reach the ground first? We see that the stone reaches the ground earlier than the cotton ball. So, we may falsely conclude that the heavier objects fall faster than the lighter ones. That is, the acceleration produced in heavier objects is more than in lighter objects. Galileo showed that all bodies, whether light or heavy, fall at the same speed towards the earth. Galileo explained that the lighter bodies fall at a slower rate due to the resistance of the air. Later, Robert Boyle proved this experimentally. He placed a coin and a feather in a long glass tube and evacuated it with the help of a vacuum pump. Robert Boyle observed that when the tube was inverted, both the coin and the feather reached the bottom of the tube at the same time. Thus, he concluded that the acceleration produced in all the freely falling bodies is the same and does not depend upon the mass of the falling body.
Now, let us understand gravitational potential energy. We have studied potential energy in last standard. The energy stored in an object because of its position or state is called potential energy. This energy is relative and increases as we go to greater heights from the surface of the earth. We had assumed that the potential energy of an object of mass m at a height h from the ground is mgh and on the ground it is 0. When h is small compared to the radius r of the earth, we can assume g to be constant and can use the above formula mgh. But for large values of h, the value of g decreases with increase in h. For an object at infinite distance from the earth, the value of g is 0 and earth's gravitational force does not act on that object. So it is more appropriate to assume the value of potential energy to be 0 there. Thus, for smaller distances, that is heights, the potential energy is less than 0, that is, it is negative. When an object is at a height h from the surface of the earth, its potential energy is given by the formula minus capital G, capital M, small m upon r plus h, where capital G is a universal gravitational constant, m is the mass of the earth and r is the radius of the earth. So students, let's quickly revise what all we have done till now. We have studied free fall motion of a body and understood gravitational potential energy. What is free fall motion of a body? Whenever an object moves under the influence of the force of gravity alone, it is said to be falling freely. When a body falls in air, there are three forces acting on the body. First, the gravitational force due to the earth acting downwards. Second, the force of buoyancy due to air acting upward. Third, the force due to friction with air called air resistance acting upward, being always in the direction opposite to that of the velocity of the body. Under certain conditions, the force of buoyancy due to air and friction with air can be ignored compared to the gravitational force of the earth. In that case, near the earth's surface, the body falls with almost uniform acceleration, small g. So, whenever a body moves under the influence of the force of gravity alone, it is said to be falling freely. Strictly speaking, this is true only if the body falls in vacuum. Then we had seen gravitational potential energy. What is gravitational potential energy? It is the energy stored in a body due to the gravitational force between the body and the earth. Gravitational potential energy of a body of mass small m is given by the formula minus capital G, capital M, small m upon r plus h, where capital G is the universal gravitational constant, capital M is the mass of the earth, capital R is the radius of the earth, and h is the height of the body from the surface of the earth. So, some questions have been given to you. Answer them and complete your work. Stay at home, stay safe and enjoy studying.